So there's two types of accounts specifically on Ethereum. There's either enterprise or public Ethereum, it doesn't matter. There's wallets, POA addresses, and there's smart contracts. And you can either have a transaction with a smart contract or with a wallet. A wallet's just a transfer of value. A smart contract actually executes code and does something. It may do something like transfer a token, but it does something, right? So, on the Ethereum network, about 96% of transactions in the last 7 days were successful, with about 2% actually being failed transactions, 1.3% being replaced or lost, or replaced transactions, and there's about less than 1% that are actually lost. You define a lost transaction as you submitted a transaction, you waited for 24 hours, and that transaction was not completed. So that's a function of confirmation time, and the way that Ethereum works is that there's something called gas, where you actually pay a fee to the miner to incorporate your transaction, and depending upon how much it's an open spot market. Depending on how much you bid, the miners will prioritize whether your transaction gets incorporated or how long you wait. In times of high network activity, gas prices increase, you may wait longer. We mark a transaction that has been sitting for 24 hours and has not been incorporated into a block that's lost. We track those, and we recheck those off as done if they're incorporated back. But it's interesting to know that things can, like if you do a transaction with Starbucks, you expect to kind of see that pay your credit card tomorrow. You don't expect it to come in 30 days, right? But given the incentive structures and how incorporating the transactions into blocks based on gas prices in the public Ethereum, you can wait, depending on how long, how much you did. So another design component of Ethereum is it's designed to be a trustless environment where it can operate where a large percent of the network is hostile. And hostile really means that you are trying to alter the history of the immutable record. That's what really it means to be a hostile miner, right? There's something in all proof of work systems, proof of work consensus mechanisms for public Ethereum as well as Bitcoin and a few other chains. They all talk about the civil attack or 51% attack, right? So there's some metrics that you need to be monitoring whether you're trusting a public chain. No matter whether you're trusting Hyperledger or you're trusting Stellar or you're trusting Ethereum, you need to understand what is the trust mechanisms, what are the metrics for those trust mechanisms, and what are the incentives and rewards and punishments to participate in that ecosystem. In public Ethereum, it's proof of work, so the incentives are the block reward for finding the next block based upon the hashing algorithm. And with Ethereum, it's a little bit different than with Bitcoin, where you're only rewarded for finding the block. We also have this concept of uncles. And uncles means you simultaneously or close to simultaneously found a block, but you receive 2/3 of the reward of the person that found the block. And that's to reduce centralization, so you don't have to have a high-speed server or a high-speed network. You can still run a miner at home. But there's a cost with that. The cost is if you have more than this number of uncles, if you're greater than 25 uncles per 50 blocks, so the number of hashing power to do a 51% attack actually only takes 38% of the network. So if you think you're operating in this trustless environment, you actually need to measure and monitor what is really happening to know the healthy state of the overall network. It doesn't matter if it's Ethereum, it's any blockchain, whether it's public or private. You have to understand the consensus mechanisms and monitor those to know that you're operating in a healthy state. So this goes into saying that really incentives do drive behaviors, and the whole thing that's happening in the blockchain is this crypto economics incentives to drive people's behavior to participate or to mine blocks or to provide computing power. You really need to understand what those incentives are because there's continuous distributed denial of service acts. there's miners that are optimizing for their own best interests, and there's lots of people out there trying to hack and exploit contracts. And this is interesting. It's Ethereum is several years old. Any blockchain that stood up today has to withstand the kind of test of today. There's 20,000 nodes in the Ethereum network. It's the highest it's been is 45,000. So in order to stand up a new competing blockchain, you're going to have the world basically trying to game and hack or do whatever. So you really need to monitor what's going on. Yeah.
So, about the session.
Yeah.
So the incentive to reduce attack is the possibility of attack.
No, the uncles are really a mechanism to create kind of robustness in the chain and reward other people so it doesn't get all consolidated into people with ASICs and high-speed data centers, right? So, but what it is though is when you look at the uncle count over time, it gives you the ability to understand if there is a denial of service attack, or if your network slows down and your latency increases, the number of uncles will increase. So you can actually see is somebody doing a denial of service attack when you look back when there was the DAO or when you look at other things, you can see massive spikes in uncle counts. Actually, I think that previous slide showed, that was what I planned, sorry. Did you see the line where it's 25 up there at the very top of the slide? When the uncle count reaches 25, the 51% attack only takes 38% attack of the computing power in the network to execute it. And you can see pretty regularly, it encroaches upon that. So, if you were spinning up some type of new consensus mechanism or whatever, you have to understand that people are playing the crypto economics incentives, right?
Do you think that has to do with the almost 20 to 30% anecdotal number we're seeing in attacks, successful attacks?
I don't know. Yeah. So the point that I want to make here though is that incentives do drive behaviors, and specifically in proof of work. And if you're looking at Quorum, which is enterprise Ethereum work, you're looking at they use Raft or Istanbul Byzantine fault tolerance, or if you look at Hyperledger, they have different consensus mechanisms. You need to understand what consensus mechanism that you're using and what are the knobs and dials on that, because that's going to be what enables you to have trust that you're trying to get from that network. So let's look at some of the incentives and behaviors of miners. So we had somebody in the Ethereum Foundation at the Taiwan Scaling Summit. They were like, hey, do you have any idea, based on the data you guys collect, what's the behavior of miners? Do people actually, as a strategy, mine empty blocks? Because if you actually sum the total transaction cost or the transaction reward in a block, it's not nearly as much as the block reward. So they believe that people will employ different strategies to optimize their returns.
Spark pool and nano pool of examples.
Mint blocks to incorporate transactions in those blocks. So what we did is we took the addresses of all the mining pools. We looked at the last 5 million blocks, which was about 3 months, and then we just did a distribution and said, what is the behavior? And what you have here is the number of blocks mined, or the number of transactions per block, and then the number of blocks that actually had that. And so what you see here is that Spark pool and Nano pool, and I'm not calling out specific pools for any particular reason, it's just what the data is. And this is not saying one pool is bad or one pool is good. All we're showing is that people employ different strategies to optimize based upon the rules of the game. So the rules of the game define your consensus the consensus mechanism defines the rules of the game. So therefore, people are going to optimize based upon the rules that you have given. So here's 2 examples of a fairly normally distributed load where the red line, vertical line, is 120 transactions per block. Then you start to see that there's other people that employ I'm going to optimize for some over here. I'm going to optimize for some that have less than, this is 100 transactions, here this is 120. So you can say that categorically, the majority of the transactions they mine are less than the average per block for the entire network. So they're optimizing on, can I mine that block faster by incorporating less transactions? You have a question?
So it's not the average, but not full of the.
No, for the entire Ethereum network for the last 5 million blocks, which is roughly 3 months, there's 120 transactions per block, right? So then here we find there's people that just go for it, and they're like, hey, these guys as a strategy are incorporating like 10 transactions a block. They're like, forget the normal distribution, we're gonna optimize the min to block as fast as possible so we can be the next in line, so maybe we can get that next block, right?
Is there is it proven that if you have fewer number of blocks, you would have that the hash would be more easy than you have more blocks, more transactions?
I'm sorry, can you repeat that question?
Is there like a whether you have how many transactions you have faster unlocking?
Yes, so there is a balance in proof of work. So there's different consensus mechanisms for different blockchains, but specifically in Ethereum, there's the aggregate hash rate of all of the computers that are hashing to try to find blocks is balanced by the difficulty, which keeps things on a linear slope. So you can keep, and that's what is controlled the block, the block time. So the average block time in Ethereum is 1 block every 15 seconds, and that is controlled by a balance between the hashing power and difficulty. The same thing happens with Bitcoin. Any proof of work has the same balance. Different consensus mechanisms have different things.
The question is it's easier to mine because that that was my mind, a zero-link block and you arbitrary large block up to a certain small factor. The only thing taken with that is that some people would just game it and start the race.
Well, exactly. It's the race to the next block. That's exactly what it is. They're trying to get that second or millisecond, it's like high frequency trading. They're trying to just be a little faster than everyone else. Yeah. Yeah, exactly. Yeah. So the next thing that's really interesting too is, so gas price is kind of it's literally the gas the cost of gas at the gas station. If you have a Suburban and it's 6 miles per gallon and you want to drive to Tahoe, where you buy your gas is going to dictate the cost of your trip, right? So we did some analytics that looked at the vertical lines here are each block. So these are all blocks. And we have this in our platform, right? But what this shows you is, looking back through history for each block, how long did people wait and how much did they pay? And the interesting thing is that in some cases, the size of the dot is how long they waited, the height is how much they paid. So it's actually interesting is that sometimes it doesn't matter how much you pay, you kind of wait at the same time if the network is not busy. But in instances when the network is busy, you can absolutely get in front of everybody else by paying more gas. But you kind of have to be aware. So in our platform, what we show is we take and we look at 200 blocks, we do cluster analysis, we do 4 linear regressions, we project forward and say, if you pay this much, you should wait this much time. And then this is a view which says, this is how long you've actually waited and the number of transactions per block. And then you have to actually also look at all of the pending transactions, which is your book of trades that kind of shows you what's going on. I'm almost done with my pitch here, or with the presentation. So what we do is there's about 1.6 million smart contracts on chain. Every single block, we take and we look at, was a new smart contract created? Was there a transaction that happened to, if it was a smart contract was created, is it ERC20? Is it ERC 721? What type of smart contract is? And then we instrument all of those. Then we rank all of those so we can see by transaction volume, by token velocity, all of the smart contracts, and this gives you a mechanism to navigate kind of what's happening on chain. And then we have the ability to drill into every single smart contract, and we instrument 1.6 million right now. and have the ability to set alerts and analytics and be notified whether your transaction volume spiked, or your token velocity increased, or your inbound or outbound calls increased. It's very much application performance management plus Mixpanel plus Splunk for blockchain is what we built. And then you can see the real-time market depth of who is bidding for what on what blockchain. And why does this matter? So we have the ability to set alerts for every single panel that we show. And it's, from a security perspective, it's pretty interesting. So we identified on our testnet, so I can't really brag too much about it, but we're doing some basically anomaly detection on machine learning for every single smart contract. And we watched the Digi chain batch overflow exploit happen, where there was about 20 contracts that were exploited, and we were able to, we actually didn't know if there was something wrong with our code, this was on our staging environment, but we started getting all these alerts, and we're like, wow, this contract went from 4 transactions a second to like 4,000 an hour. We're like, what is going on, right? So, you have to be able to, the point here is that no matter what blockchain you're using, whether it be Hyperledger, and like I said, we support all of them, right? But whatever blockchain you're using, you actually have to understand the infrastructure, the smart contracts, the transactions, what are the KPIs, what's the health. It's just like any other system, and blockchain is really just an evolution of classic distributed systems with trust, with the ability to monetize on a per transaction level in the smart contract. So you really need to have the tools and instrumentation that you would run any production software. And that's what we do. So if you're interested in our platform, it's free and available for public Ethereum. We just launched the testnet yesterday, where we're launching 2 new public chains in the next, hopefully next few weeks. Yeah, go ahead.
So what's the difference between the data you find in Ethereum compared to Hyperledger?
So for Hyperledger, it depends, like what's your, so Hyperledger is a private permission consortium chain, just as, and I'm at the Hyperledger meeting here, so I want to be really respectful, but you also have, Quorum or Enterprise Ethereum, right? The technology behind us, it's still a distributed ledger, right? And it's running private permissioned stuff. You still need to monitor it, but fundamentally, you can look at all blockchain as, is it a UTXO, right, unspent transaction out? Is it account-based, or is it a directionally cyclical graph from the storage layer? From the virtual machine or smart contract layer, there's really only 2 types. There's the Ethereum virtual machine or WebAssembly, right? And on top of that, the consensus mechanism. If you can monitor and instrument and abstract away those things, you can understand what's happening on any blockchain. Because there's like 1,500 projects, and they all are like differentiated. At the end of the day, they're not that differentiated. There is some amazing stuff that's happening, but it's an evolution. It's not, there is a revolution going on too, but yeah, so that's how we look at the world, and we are, instrumenting, we're working with a few enterprises, and we've instrumented every single smart contract at Ethereum, and we're adding 2 more public chains, and we have 1 customer we're working on with Hyperledger right now. But I can't show you a demo of the Hyperledger stuff.
Maybe I guess, what is the business model?
So our business model is, and this is free, we don't do any advertising, and we don't sell people's personal data. We will likely do some type of advanced search, some domain-specific dashboardings, type Splunk-esque type functionality, and then we also will have inbound APIs, like we're working with 2 other chains, and they will push us their data. So we have a data ingestion model where we give them an API key, and then they push their data, they define their schema in JSON, and then they push it to us. We ingest, instrument, do rule engines, real-time events and alerts, machine learning for anomaly detection, providing dashboards. And one of the things people always say is, well, this is not decentralized. Unfortunately, you actually can't do what we do using like IPFS today. The transaction throughput and what have you is just not there yet. But when it will be, that'll be amazing, because then my AWS bill won't be $20K a month. So, any other questions? Yeah.
How does it change from public to Hyperledger?
Yeah.
Commission
So I think that the key thing on public, so on enterprise chains, they are usually permissioned and private, and there's different mechanisms for that. Like JP Morgan Quorum with Ethereum, they have basically your trading partners, and you each keep copies of your transactions, and those are, you basically checkpoint those to public chains, so you know a transaction happened, but you don't know. Hyperledger, it depends, right? On which, are you using Indy, or are you using, Fabric, or are you using, right? It really depends. It's Hyperledger is many things, as everybody knows here. It's like, yeah.
I've tried to do some analytics on the Ethereum blockchain, and had a number of time just ingesting the whole thing and making it computable.
Right.
And tabular JSON. How did you go about that?
It's really hard.
What did you do?
So here's the net is that, why is it hard? So like my team, we built a data ingestion pipeline that we did 4 terabytes of social media graph data, real-time analytics, and $1 billion of social media spent through it. That was way easier than doing it for something as simple as the Ethereum. And the reason is that Ethereum has the blockchain, and the transactions that happen on chain are, that's just a transfer of value state. You don't get internal messages, you don't get token transfers, and the only way to get that information is to actually replay each block and in each internal transaction and index and sort and count for those. You have to really understand the data model. It's pretty complex. It's really elegant, but it's definitely not straightforward. And then you also need to be able to do validation to know that you did it correctly. So like what we do is we ingest the block, we do a Merkle proof to verify that our data is correct on chain. We got that from our enterprise customers that we're working with, because they're like, hey, I love this. I want to have time series historical data with the ability to do full text search, but how do I know your data is right? The data on chain is the authoritative source of truth. So what you have to do is you have to be able to compute the Merkle proof on a per block, per transaction, what have you, and be able to do that. So there's some art and some science to it.
Question, how do you keep up with the eventual consistency issues around that? And what's a reasonable eventual consistency window?
I'm sorry, I can't hear you.
How do you keep up with the eventual consistency issues on basically a massively distributed encrypted database? And what is the window for QoS that you guys think is reasonable?
Right, so you're talking about finality is what you're basically talking about. So on Ethereum, it's about 6 blocks. So what we do is we collect, and then we do a couple of things. One, we're making sure that the data in our database is actually continuously scrubbed so it matches on chain. But the stuff that may have uncles and there may be forks or whatever, you have to basically keep in key value store and be able to verify that until that has been finalized and brought on chain, that you have to be able to verify that. So
is a day like
there's no trick to it. It's just, and for pending transactions is really difficult because for example, Ethereum, there's 20,000 nodes running globally. You have to recollect 70 to 95% of the entire pending transaction pool on a daily basis on every single block. But sometimes you don't get everything, right? But once the transaction's incorporated into chain, you definitely have it, right? So there's not any magic. It's just hard work and discipline.
Is the 24 hours of Rendo just like your earlier data? Is that the window you look at about 24 hours?
No, we do it every single block that's finalized. And we scrub because I don't think it's been released yet, but within the next couple of days, you'll click a button and you can verify. And that's super important for any chain. Like we're not doing it just for Ethereum. We're doing it literally for any public chain and as well as for private chains. Single pane glass kind of make it, because the problem with blockchain today is that even though it's open, even though it's transparent, even though it's accessible if you have a hash of your transaction, it's not easy to get. And it's not easy to know that you have all of the data. It's really not. So we're making it accessible, easy, transparent. It's a total picks and shovels play. Enable the ecosystem. That's what we're doing. So, and literally you can't, if you have a Hyperledger project, you cannot, or a Quorum project, you can't go into production unless you can monitor. It's that simple. We had multiple conversations going on where we're talking to the CIO and we're like, well, yeah, this is cool, but how How do I know it's running? Who do I call when it's broken? How do I know when it's broken? I have an SLA. I lose my job. This is classic enterprise stuff, right? So if you want to enable people to embrace blockchain, and you look at the enterprises today, SAP has 40 proofs of concept. Oracle has 60 proofs of concept. IBM says that they have 400. I don't know if they do or not, but that's a lot. Intel has a huge list. There's like at least 500 enterprises that are experimenting with blockchain, primarily around supply chain and trade finance and things where there's distributed networks of trust. That's a really killer use case. But you still have to be able to monitor to know that you can trust the trustless network. Okay, way too much.
Two more questions for you. We got one over the corner here, and then we'll go to you next. So there, it's over.
Just looking forward a little bit, when Ethereum is going to have all these side chains where things are less transparent, how would that affect what you do?
Yeah, so it's actually not going to become less transparent. You'll still have the same transparency. It'll just be a little bit more difficult to get. But the way that we're looking at the world is there's going to be many public chains. There's going to be many layers in between those. So if you look at Interledger from an enterprise perspective, you look at Plasma, you look at Polkadot, you look at Cosmos, all of these, you look at state channels, right? You look at all of these are mechanisms for doing atomic swaps between chains to be able to have chains interact with each other. That's a super critical piece that needs to be instrumented as well, and we're working with a couple of those organizations who are a small team. So, but yes, you need to have, because if you just have transparency into one blockchain and you try to transfer between and you lose it, it doesn't help, right? So you really need, and where like we won't do is we're not going to do all the the Z caches and the Moneros and all that stuff. That's privacy stuff. Like we're more focused on business, right? Yeah.
One more.
Yeah, I think that's an implementation. My question is about data, doing analytics and monitoring on blockchain, which is like we have some lot of data. At the same time, we have GDPR. And if you're doing a lot of monitoring and surveillance on the data, how do you do it?
Yeah, so I got it. I can repeat it. Yeah, so what about GDPR, right? So PII, right? We're not doing PII data, and I've talked to my attorneys, because I had one of my customers, and I was like, oh my God, what did I just do? And they're like, no, you're ingesting public data, and it's not people's email addresses. It's pseudonymous hashes of address, so that was what my counsel told me. I don't know. Let's see. Yeah.
Great. One more if you want. Anybody? Okay, great. Last question. You said you're working with enterprises, right?
Yes.
That won't be public data.
No, that won't be public data. So the way that we, our team has a pretty solid DevOps background, so everything's containerized, and we can deploy into somebody's VPC just as fast as we can deploy through our continuous delivery on a daily basis. We ship like 5 times a day. We spin up the whole environment, we go, boom, point aside your node, we ingest the data, we index, it's entirely private and permission. And it's really interesting is that for us, it's great is that if you have a multi-party permissioned blockchain network, each party only has visibility into their data and then the shared data. So that means they're all my customers, right? So, because then you need to be able to trust the public chain, and then you need to be able to have visibility into your stuff.
Just any use cases that stand out on the enterprises?
I think the killer use cases for all the enterprises right now is we're the SAP.io incubator, and the tip of the spear for SAP is all about supply chain management. It's all about trade finance, and there's all kinds of really killer use cases there. IBM, that's their use cases. Oracle has some really, really interesting stuff that they're working on conglomerates that have done lots of acquisitions of private consortium chains where they own all the intermediaries, right? So there's all kinds of interesting use cases. And then there's a lot in the automation of trading, like some over-the-counter credit default swaps. IHS Markit has publicly stated and it's all over the news. They're going to do $7 trillion credit default swap trading. JP Morgan has a project that is a public project that they're speaking about. So you can Google that, and that's a some type of a credit market as well. So markets where you can disintermediate people that add little value, and it's really, this is like almost an Accenture commercial, but it's business process automation is really what it is. And you put things into a smart contract so it's on chain, so everybody has transparency, things happen automatically. So this has been a story for 20 years. It just happens to be the new thing is that it's being instrumented in smart contracts that you can monetize on a per transaction basis. Yeah.
Just to add, one of the things that Sean and I were talking a while back, and mentioned was really found for me, was that in addition to you doing automated processing through smart contracts, so you're doing it upfront in the beginning to really validate, is this form, is this trade, is this transaction correct? And so that you reject it and then you go back again. So you're doing this a lot of programmatically in smart contracts, just to be able to validate data and you're front loading the transaction ahead of time. Through that. The second is that removing the transaction layer from these private databases, having their own Oracle instance and doing their own separate schemas. What you're doing now is doing a very universal layer of transactions. And now you're adding on top of that, you're going to then take those transactions and then with metadata and other things, you'll move it then into your own private necessary needs. But you're actually moving up that transaction layer to something that is much more transparent and inspectable.
Yeah. So
universal. So it's a really interesting, profound transformation.
Another really killer enterprise use case that Oracle and SAP are both publicly talking about, but like if you Oracle e-business suite, if they just envision, right? If you were to, I don't know if this is what they're doing, I've heard people talk about this publicly, so I don't think I'm, envision that you have a Oracle program, right? And you have hundreds of customers and systems integrators and developers, and you have a platform like eBusiness Suite or SAP or whatever, and you have the ability to today, your systems integrators sell modules into those big, heavy, behemoth software. Imagine if you can have a consortium chain where something gets monetized on a per transaction basis to be able to sell your custom software as a module that just gets called, transacted on a consortium chain and plugged into the enterprise. That's why I said it's AWS Lambda with monetization on a per transaction basis. It enables businesses to integrate and interoperate in a trusted way, and they can monetize them on a per transaction basis. It's really, really disruptive. So.
All right, let's big round of applause. All right, our next speaker is Joel Deadly from Corda. He's talking about distributed decentralized identity.
Yeah, decentralized identity.
Decentralized identity. A couple things. So I guess the restrooms are around to the back. Yeah. And then Joel can set up. And then I think at the end, just a brief announcement, if you can just help take care of the trash, and then we'll need some help with taking a chair, breaking the chairs down, and put them up here. So if you stick around and assist, I would be very interested. All right. Joel.
Yeah. Hello? Cool. Let me get started. Look. Okay. Cool. Yeah, so my name is Joel Dudley. I'm co-maintainer of a blockchain platform called Corda. And what I want to talk about in today's presentation is the concept of identity today and the way you can decentralize identity using blockchain. And this is mainly led by a Hyperledger project called Libby. It's completely open source. So we're going to talk about that, and also some of the work we've been doing with Corda to interoperate with Hyperledger and interoperate with these decentralized identity systems. So I'm going to start with a slide that's in every identity presentation ever, which is this one, this New Yorker cartoon of two dogs on the internet. If you haven't seen this before, it's supposed to be your first presentation on decentralized identity, so don't worry, it's not complicated. But this is a 1993 cartoon about how broken identity was on the internet at the time, right? So you have two dogs and you're on the internet, and no one can even tell you're a dog, because there is no identity on the internet. And identity was broken then in 93, but it's still broken now, it's as broken. And if you think about it's broken, I mean, I break it down really into 4 categories. The first problem you have is that your identity online is fragmented, right? So you have different accounts, different logins, you've got certain information that sits with your bank, you've got certain information that sits with mailing lists, you've got certain information that sits on GitHub. And there's no way to keep that updated, and it's all fragmented, you don't know where it is. The second problem is it's incredibly manual still, right? So fine, if you're signing up for a user account, it's okay, but if you think of stuff like trying to get online banking set up, it'll involve telephone calls or in-person meetings. The third thing is it's based on blind trust, right? So, I mean, you can imagine, for example, I don't look very old, but I've been over 18 on the internet forever, right? Because every time I go on a website, I just click I'm over 18 and that's done. And that really is just a lot of the identity we do see on the internet is based on blind trust. You know, your location, your age, all that stuff. But the biggest problem I'd say is that you don't control your identity. So if you have your identity online, you pass it off to some company or your bank or some mailing list, then that's essentially out of your hands. And you can never tell where that data is going to go. Someone gets hacked, that data can be taken away. A company acts badly, that data can be taken away. And what we really need, instead of all this, is some kind of digital credential, right? So this is a simple example here. This is the driver's license, let's say. And you can see, I mean, it's easy to see how it works, right? It's basically a data object with some properties here, you know, ID, expiry date, first name, last name, and then 2 signatures. So these are the same kind of signatures you see in Bitcoin, blockchain, etc. We've got a signature from the issuer. So here, let's say this was issued by the California Department of Motor Vehicles. So that signature is there to say that this data is correct, right? So they're attesting that these are the people who issue the driver's license. They're saying this is really the data hasn't been tampered with, and to tamper with it would break this signature. We also need this owner signature, right? So owner, me, Charles Ledley, I'm signing to say this is actually me. So even if the issuer were to sign, if California DMV were to sign, they can then someone else could go out and use my driver's license. So you need the second signature from myself to say I am the person sharing this information with you. Does that make sense? And so we can look at how it's going to work, and a very simple example would be this. So let's say this is me, and that's the DMV, and this is Alamo, the rental company, and I want to rent a car in this digital credential world. So first thing I need to do is create a key pair, right? So I'm going to keep the private key public, and I'm going to use the that to sign to prove that that the credential belongs to me. The next thing I do is I get something called an attestation. So an attestation is just a person of trust, a person with some kind of authority, saying that you are giving you some kind of credential. So in this case, it will be the DMV giving me a credential saying I have a valid driver's license. So I say to the DMV, you know, here's my driver's license, I own PubKey X, and they'll send me back a digital driver's license credential signed by them and saying it's owned by me, PubKey X. It's signed by them, so that means you can no longer tamper with the digital credential. And by associating it with my public key, then whenever I present this digital credential to someone, I can provide a signature as well to prove that I am the person who owns this credential. Does that make sense? That's what we call an attestation in decentralized identity. And then the third step is, well, let's say I want to rent a car and I send my credential to Alamo, proving I have a driving license. I send a signature, proving that I own PubKey X. And they'll say, okay, you can go pick up a rental car, right? So the technical implementation is complicated, but you can see how it's a very simple system, right? Once you have digital credentials out there that you can trust, you can move to this kind of public key cryptography world where you get credentials from issuers proving certain things about you, and then you can selectively reveal them. And the real power of this model, which is sometimes called self-sovereign identity, is that you control this credential. So you don't need to reveal the whole thing to Alamo. You just provide them a proof signed by you that you have a driver's license, or you might provide them your age but nothing else, or your place of birth but nothing else. You remain in control of the data and never moves by most servers, they just hit signed proofs. The only big problem we have with these digital credentials is this. So how do you map these, to verify these signatures, you need to know the pub key behind them. And that's the big problem you're going to have. So how are you going to know that the California Department of Motor Vehicles has the pub key that would mean that signature is valid? You need to check that somehow, right? Otherwise it's just a random hash of data. So what we need is some way to link California DMV to a certain public key. And similarly, I need a way to link myself to a certain public key. The solution to date has been certificate authorities. So basically, there'll be companies out there that that go around and just do KYC on people and say who's who. But it's a very centralized market. There's a real small handful of root CAs, and there's CAs who kind of intermediate CAs who sit on top of that, and their job is to provide people with kind of proof that they are who they are. So that's the little green padlock you see when you log onto your bank or you log on some big company's website. And the big problem you're going to have with that is that it's very expensive to get a credential, to get a certificate. And because of that, no one really has them, right? There's companies that have them, but no individuals have them. It really restrains the space within which you can use digital identity. If you had a digital identity for myself, the owner of this driver's license, that would be great. We can do the things we just talked about. But in the current CA world, I'm not going to go through the pain and the KYC process and the expense of getting a certificate for myself. I mean, I live in London, you can imagine people in much poorer areas being even more out of reach and yet needing a digital identity even more. So what we have instead is this project, Hyperledger Indy. It's an open source project, and the goal of Hyperledger Indy is to use the blockchain, a blockchain, as the root of trust of this network. And to basically, instead of some certificate authorities controlling who's who, you use this, you register these identities on a blockchain, and you use these identities. So identities effectively become free and free to use. How does this work? So in Hyperledger Indy, you create this decentralized identity system, and the transactions on this blockchain aren't, Bitcoin transfer of value or generic smart contract executions. Most of the transactions, there's other types, but most of the transactions will be going towards creating these immutable digital identifiers. And you just create them by generating a random number, checking it's not on the ledger. So, anyone can create them. You create them for yourself. And they look kind of something like this. So this is an example I stole from another presentation, but you can see here there's a lot going on, but basically you're mapping a certain DID, what's called digital identifier, to a DID document who says what's the key, the public key that owns that digital identifier. And you can see importantly here, these DIDs are anonymous. This is going to come back later, it's important, but in the Hyperledger Indy world, you can create as many digital identifiers as you want to prevent the risk that if something goes bad in relation to someone using a certain digital identifier that reveals certain things about yourself, if you create a different digital identifier for every transaction you have, then it will be, even if one private key, for example, is broken, then all the other identity arrangements will stay intact. And then, because anyone can create digital IDs, anyone can now issue credentials, verify credentials, and revoke credentials. Okay, because you have this this public key, this digital identity. All you need to do is go out and sign with that public key, or that private key, and then anyone can check that you, that person who has that digital identity, signed that document. Does that make sense? And so you can see here an example of a verifiable claim. So a verifiable claim is what we talked about earlier, it's just a claim that someone does something. So here you can see, for example, we've got the DMV up there, the issuer is signing this claim that the person with ID X is over 21. And then I can present this to people, I can serve this to people. And you can see that no one has seen my driver's license, no one controls my driver's license, no one's storing it on their database. But I can prove, without revealing the entire credential, that I have that credential. Okay. And then what's interesting is that the credentials themselves stay completely off-chain. So the Hyperledger Indy blockchain is not a blockchain for storing people's credentials. They store the credentials themselves. It's just a way of publishing a specific identifier with a specific pub key to solve that problem we talked about earlier, right? So how does the DMV prove they own a certain public key? And so there's nothing on the platform that would really reveal anything. You can choose if you want to associate a digital identifier with a well-known name, for the DMV, for example. But in practice, if you go and look at blockchain, do analytics on it, all you're going to see is mainly a sequence of people just issuing these anonymous digital identifiers. So we can work through an example now. We go back to this car rental example. So here I've got me and the DMV, the Alamo, the car rental company, and this digital identified blockchain. The process is a little more complicated now, but obviously this would be handled by code. But it is a way of providing that clear mapping between certain identifiers and certain public keys. So I'll talk through each step. There's a lot of steps, but hopefully it all makes sense. So the first thing is that I create a new digital identifier for speaking to the DMV. For any relationship you have on this kind of blockchain, you create a new digital identifier because, as you said, that prevents the correlation risk. But in your own wallet, you'll keep a listing of the DIDs that you own, but not by looking at those DIDs, can look at all the DIDs and look at the various sets of transactions and work out who you are, for example. So if you imagine that someone, let's say a bank was using a DID and they used a DID to purchase certain assets or purchase certain properties, then eventually you might be able to correlate based on certain transactions who they are. So you always want to create a new digital identifier for every transaction you enter into. Then I'm going to look up the DMV's DID, for example, on their website. You find out what the digital identifier of the DMV is. You go back to the ledger and you map that DID to, you go look up that DID and get an endpoint. So we looked at endpoints a few slides back. If I go back here, you can see that in a digital identifier document, one of the things you list is an endpoint. And that's basically a place where you go to speak to that person to create, to request a credential, to attest something. As we said, all that information happens off-chain. So as soon as you go into the process of negotiating a new credential and making a claim, that happens, over encrypted, standard channels. This doesn't happen on the blockchain itself. So here we are. And then the next thing we do is we use this DID to create a secure connection to the DMV. And I can send my DID, and in this case, I'm going to send my proof identity, right? So I've created my credential here. I want to get the DMV to provide some attestation I am the owner of a digital driver's license. And the DMV will just send back a signed digital document, a credential, saying that I am, who I am and I have a driver's license. And this stays off-chain again. So here's just over a secure channel. This isn't involving the blockchain at all. So that's halfway through the process. We've got our credential now. We have this credential that says that the DID that we own is the owner of the digital driver's license. And the next step now is to speak to Alamo. So we're going to go through the same process again, creating a new DID to speak to Alamo, looking up Alamo's DID on the website, then going and getting the endpoint for Alamo. That's all the same as we did last time, right? There's just this process, this lookup to go and create a secure channel to speak to some other digital identifier on the network. And then I get to this point, and so here I'm going to create a secure connection to Alamo and send my newly created DID. And what Alamo is going to send back to me is a proof request. So they're going to say to me, I want you to reveal part of the credential that says that you are the owner of a valid driver's license. And so I'll send back, I'll create this proof, and so in practice this uses zero-knowledge proofs at this point to only reveal certain parts of each digital credential. So I send that across. There's one last step Alamo needs to do, obviously. So Alamo has just seen me send across this thing. It says it's signed by the DMV. We're back in the same problem we were before, right? So how do they know the DMV is the owner of that public key? And so at this point, the Alamo needs to retrieve the DMV's DID from the ledger. It uses the public key in that to verify that the credential is signed correctly and that the right credential has been revealed. And it sends back the authorization to get the right part. Yeah?
But it didn't seem like the DMV made that call to the ledger.
Yeah, so the DMV doesn't need to make a call to ledger. So the DMV just provided the signed credential to you, the individual, so to me, in this case, Joel. So it sent that back to me. I store that locally on some piece of software. It stays off the ledger. And that's kind of the whole point of this stuff. So the blockchain is there to create a mapping of identifiers to public keys. It's definitely not there to create a public ledger of everyone's credentials. Because the key is control of your own digital credentials. Yeah? Yeah, so the complicated part always is then how do you know a certain did corresponds to a certain person, I guess is your question. So that's, there's various ways you go around that, and there's kind of three big ways that they talk about. So the people who kind of invented this technology, the people behind the Hyperledger Foundation, thought of three ways. One is just to, if you know the person, or that information is published in a trusted place. So if you think of the DMV, they could publish what it did on their website, and you know it's there. Right, so that's one way to work out that identifier corresponds to that person. The second way is for that person themselves to have credentials from people you trust. So if you imagine there's some root on the network, there's someone you trust absolutely, like the US government, and they sign a credential that... I know I do. But if they sign some credential saying that the person, and the credential in this case would be the fact that the DMV is the owner of the digital credential that says that they are the DMV, signed by the US government. So you get what's called a kind of a web of trust. And the third way is just if you see other people trusting that person, if enough people trust it, then you'll trust it. And that's the real web of trust. And it's a difficult one, so it's kind of back to the kind of PGP model of identity. And the problem you have in that kind of model is that essentially you need to start deciding who you're going to trust. So I think with certificate authority, it's easy because I think everyone just assumes that the 100 or so certificate authorities are trustworthy and they just trust the green padlock. But in practice, you are trusting those certificate authorities are good. And it's kind of the same here, except you're much more granular in these decisions. So you could choose to trust certain people as having, if someone else says you can trust this guy as the DMV, then you might trust that other people might make a different decision. And the building of that web of trust is one of the big things in what the Hyperledger Indeed project tries to do. They started with some stewards who are these original trusted parties on the network, and these guys the idea is these guys will then onboard other people and go through a KYC process and then sign to say that these people are who they say they are. But it's definitely kind of, everything else is technology, it's blockchain, and that becomes a governance issue, and it's the kind of a much more human, it's kind of an area of presentation itself. Yeah? Yeah, so anything kind of did. So I'll talk about some of the use cases we've explored in the set, but one of those use cases is using our platform Quarter to create a new found a new company, and then as part of, after doing that process, you go to Hyperledger in one of the networks and issue a DID for that company, and then it could grant power of attorney, it could have representation rights, etc. So anything is an identity. It's not one per person, and it could be anything. It could be a piece of art in theory. I guess the thing needs the agency to do the signing, but I guess it could be a robot in practice. Yeah. Right?
So the process that you're describing it is booking a car, not renting it. So renting it, you need to be there first. And then you can check the transaction, verify that it's the same person.
No, so yeah, sure. So the question is, in this case, what if you're renting a car? How do you prove that you are the person with that digital identity? So because that's the process that originally happens with the DMV at the start, right? So when you go to the DMV, you say, look, this is me, this is my pub key, this is who I am, and they issue the credential, and in that credential will be embedded the public key that signs it. So when you sign that document, you reveal effectively that you are the person who owns that credential. Yeah.
That's a big line. My question is about DMV is like a Department of Motor Vehicles.
I think so, yeah.
DMV is like a department, and every state has a DMV.
Mm-hmm.
I think my question is about the idea of, let's say you're speeding or something, and somebody stops you, they say, like, you're a guy who's speeding, so actually they need your driver's license.
Yeah.
Driving an automobile. If you don't have a driver's license, you get a ticket.
Yes.
So actually, I think the space we are talking about is digital identity, like blockchain. You are actually, assuming you have, let's say in that picture, you have a tag or a Chinese tag or a tag.
Okay.
A dog is one kind of dog, another kind of dog. idea of it is on the left-hand side. How will you, in a blockchain, how do you differentiate it to the Homo sapiens, who's from Africa or Russia or San Francisco? I think there's a problem there in this. I know what you're trying to do is the digital identity.
Yeah.
It's not just like an automobile, you're doing a lot of things.
It could be anything. So it's just a system for kind of giving people credentials. So the blockchain becomes the record of mapping of identities to public keys. And then once you have that, you can start to issue digital credentials. So actually, in practice, digital credentials would be something on probably like a smartphone or something, or you have a digital wallet, and that's what you present to, in some future, the police perhaps when they stop you for speeding. So the blockchain itself doesn't store any of these credentials, it just creates that mapping.
Let me ask you another question. Let's say I there's a human being there on the left side.
Yeah, it's me.
Let's say it's my cat, it's my cat and your cat. How will you differentiate between my cat and your cat on this diagram?
Well, so I think that's when you come back to the agency. So you effectively, to prove that you are that person, you need the ability to sign something with a private key, which a cat wouldn't have. So anything that can sign with a private key would be able to prove their own identity, and it's kind of because it's a public key and they only own a private key, but then signing they're revealing that they own that key. And technology-wise, this is what high-pressure Indie looks like. So it's basically a toolkit, and it's completely open source for the High-Pledger Foundation. It's a toolkit for interacting with these ID blockchains, right? So in the middle here, you have the High-Pledger Indie layer. So the Indie node is a library for running the nodes that sit on this blockchain network. An Indie SDK is a kind of a multi-language wrapper for interacting with these blockchains. So you can write in Rust or Java if it's a C integration, Python. So basically from the outside, you can interact with blockchains. Because they're only valuable because they can be interacted with, right? So you can think of, this, for example, so Microsoft, the Authenticator app, that now integrates, they've kind of done integration with Hyperledger Indie Network. So by using the Indie SDK, you can actually authenticate yourself using a digital identifier rather than using a standard, 2FA, tapping your phone kind of thing. And our platform, Corda, has integrated with it using this Indie SDK, which again just provides a bunch of libraries for reading and writing to an Indie network. And there's many others. And at the top, at the same time, it's completely agnostic. So Sovereign is a network developed by Evanim, who originally developed this software. So you can use Indie node in the SDK to connect to that Sovereign blockchain. But you can also use it to connect to other chains, maybe chains you start yourself or other competitor chains that will emerge. So although it was originally donated by the Sovereign Foundation, they've written Hyperledger Indie, I guess, because of the constraints of operating in the consortium open source model, so that in practice you can start another Genesis block and start your own network of trust and use that instead. Does that make sense? So next I want to talk about is just the integrations we've done with Hyperledger Indie. And so we've done a lot of work with Hyperledger Indie, and there's kind of two features of Corda that we... Hello? Does everyone hear me?
Yes.
So there's two reasons that we found that our platform integrates well with Hyperledger Indie. And so one of them is that Corda is very different from other blockchains in that the information on the ledger isn't distributed to everyone. So we started out as a consortium of various banks and financial institutions. And we're doing a lot of proof of concepts on Ethereum. And we did some great proof of concepts, everyone was excited, like managers were happy, but when we found that we tried to push these things into production, everyone said no. And the big reason often they say no first would be the privacy issues. So in Ethereum, everything's published, everyone go look at it, as this guy does. And that's a huge issue for businesses. And so part of this is the information is shared on a need-to-know basis. The parties involved in the transaction get to see it. And again, that's a kind of a topic for another time, how this works, but it meshes well with Hyperledger Indie because you can imagine that if you integrate Hyperledger Indie with a blockchain, it reveals everything. then you lose the whole point of hyperledger indie, which is the fact that you control your credentials and no one else can look at them without your consent, right? So a lot of work has gone into hyperledger indie to make it so that people can't just go and look at your credentials, so that they stay off chain, etc. But then you're just going to publish them to a public network, effectively. And equally, Corda is a permission network, so people have signed up onto a KYC process, which ironically happens in the old-fashioned way of certificate authorities, might move to hyperledger indie in the future. But because it's a permission network, again, you know who you're dealing with for any transactions, they're just dealing with public keys. And in turn, that means that when you do need to share some kind of private information about a customer or something, you don't share it to the wrong person of access, you're in control of it, actually. And so we've done quite a few projects now with various partners, with Microsoft and Tieto. And the one I want to talk about today, it's got a nice UI, I'm not going to demo unfortunately, is this project called Gemalto. So Gemalto is an attempt to use Indie to create a digital wallet for everyone in the world that can then be consumed on Corda and written to using Corda. So got the setup here, so this is the UI, it's better on a higher screen. This is our Indie network over here, and then we've got some nodes on the Corda network, so and so how would this work? So how does integration work? Well, the first thing you do, let's say, is you might have there's some person who is saying, I want to open an account, right? And so what they do is they use this client app to send a passport photo and photo to open a bank account, for example. And this would send a message out to this bank pay on Corda, and they authenticate the customer. This is a standard process of getting a passport photo, etc. And then they create an account on Ledger. So at this point, all they've done is, they've just taken this passport photo. So India isn't involved yet. But after creating this account on Ledger, they can write this kind of digital identity claim back to India. They can provide a credential that the person owns the account. They can also, because they've made this part of the process, create a credential saying this person is who they say the other person is that with these pieces of information. Again, they're just using India to do this, but the attestation itself stays on chain. And then this will flow back into the app as well, so your digital wallet will now have a credential that allows to prove who you are and you own an account, as long as that person trusts the bank who's issued these things, which again you would. Does that make sense so far? So this is an example of how our platform, or our blockchain platform, based on information, based on business decisions, will write to India. But it can also go the other way. So in Gemalto, if let's say a second bank is to authenticate individual, perhaps they're opening another account, for example, then the user, instead of going through the whole process of uploading a passport photo, uploading a photo themselves again, could instead just share the identity claim they already have from India. So it goes both ways. So the user can send a passport photo, and the bank can write to India, so India can become updated based on what happens on the ledger. But equally, the Corda can read what's happening on the ledger to make business decisions. So it's kind of a two-way flow of data. And then here we create an account on ledger. And importantly, you can see here that all this information about accounts, etc., because of the Corda privacy law, where data sharing on a basis won't overflow between those parties. But now let's say they want to share some information to the regulator, then they can report and send some information on the ledger to the regulator. This is where the permissioning becomes important. So because you're dealing with these permission counterparts, you have to identify the regulator to be sure they're disclosing this private information exactly right. So as I said, this is just one example of the integration we've done for both Corda and what you see in other blockchains is you always have this kind of two-way flow. So on the one hand, you can write to hyperledger, which is what we did in one of our other projects where we created digital companies using Corda as kind of a business logic execution thing. And then you create an digital entity for that company and they can start doing things. You can also read from Indie because you can have now identifiers for people as opposed to just companies. And then you can use that to have businesses. So use that to drive supply chain decisions or decisions about who's working with capital or who's deciding to trade with you. Thanks, everyone. Yeah. interesting there. So you create a credential that would be the sum of other credentials. So effectively, I think what would have happened there, and I myself am not in the team, so I might be speaking out of turn, but what you have to do is basically present all those credentials to some, let's say, credit risk scorer, and then they could issue a credential based on that credential. So they could request a proof of you having, paid off your mortgage on time, £5 an hour, and then they could, based on that, issue another credential that would be signed by them. Again, that's an application. Yeah. Yeah.
In that last slide, you showed that it was reporting back to a regulator. Is that including just the existence of an account or account activity that you're doing?
It really depends on the use case. This is just kind of a proof of concept. It's something that you could do. In practice, we have to make a decision. So it's up to the people involved to be able to. So that's not a feature of the platform. That's just a business decision about how you model flow data on that platform. Does that make sense? So you can choose to report everything or nothing. And effectively, one of the benefits here is because you're using Indeed, there's only so much it can report, only the fields that you provided to it can. Instead of just sending off your whole passport. Yeah.
How far are banks? So KYC is very sensitive, right? How far are banks along the way accepting these certified buildings?
I think the problem we still have is that even the sovereign network, which is the biggest network using India, is quite new. So they're kind of in a part like a test network situation right now with various trust stewards on it. But the network will actually have to go live. The first thing that can happen before all this stuff can start to really take off. So it's a few years out. So we're looking now at using Hyperledger India and SDKs and doing proof of concepts and whatnot to work. But in practice, using India to share real credentials is impossible for now. Yeah. Yes, sure.
Yeah. We need not go through the banks or we using our learnings. We can talk to each other. Let's say it's a license situation. Leave me and left.
Oh, so I mean, you would, yeah. So if you would create a new div between Lead, perhaps we'd use those divs to create a secure channel. I mean, there's nothing magical about secure channel. Like it's like the secure channel you use to send email from one person to another. I mean, that's not easy. But then at that point, you have to do some kind of proof request. So you'd ask me some proof, and I'd send you some fraction of my driver's license, my passport, or you send proof back to me that maybe there's some ethical supplier or you're approved by XYZ. So it's really up to you. Credentials can take any form. They can have any, just like a JSON style object. And then anyone can request proofs from anyone else. And anyone can sign anything, right? So I can sign passport credentials I wanted to. And that's where the web of trust and working out who is a valid provider of credential becomes important. Platform can't decide that for you. Yes. Yeah. Yeah, so in that case, what you probably do is you have some greater authority who is able to speak to the passport, and they can ask you to reveal the passport that said who you were. And you can do that up to them, and then you'd be in a situation where you'd be in an authenticated channel. So you could set up a TMS authenticated channel, you can have keys, but you'd also be sure, so you'd essentially see like a tiny snippet of someone's credential passport.
Sovereign software.
Yes.
Okay. So as of today, if there's somebody's establishing identity, you have to Indeed.
Yes.
So someone has an authority, even also has a similar one.
Yes.
They need to report it. So they need to talk to each other through a sovereign. Or if that's something.
Yeah, effectively you have to write a wallet that spoke to both. And hopefully you end up in a situation where everything moves to one single blockchain. There's no stopping you from getting some credentials and some requests for proof on one and then things on the other. It's just a bit of a pain once you have to integrate various networks.
questions, two more. Here.
Yeah. Core is developed by R3. So it's now an open source platform under Apache 2, but it was originally developed by R3. And it remains the kind of there's a lot of contributions coming in, but kind of the lead design thing has come from R3 still as well. Yeah.
So for on the right hand side, because they're different for every bank, there's very different KYC requirements, right?
Yeah.
So just wanted to first that if, for example, I'm a customer and I'm a digital ID and Bank A validates it, then should it follow the KYC requirements of Bank B should also be the same as Bank A? Or it's okay that there will be difference, but that's okay.
You've seen the credential and you know what that bank has done for KYC. So this again, it comes back to the trust issue. Do you trust the other bank to do the KYC correctly? So what you see is a credential signed by, let's say, HSBC saying, yes, we do KYC, and this is the truth about them. But then you might be Deutsche Bank and you might say that's completely valid credential, I'm going to trust HSBC to do that properly. Or you can say, no, I don't trust them, then you can ask for it again. Then it becomes a governance thing where it's up to the individual to decide which people they trust to issue valid credentials and not. So as I said, I mean, I can issue credentials to people who I did saying they are, they say they are. No, HSBC trust them.
One more, we'll stick it on in the back here.
So we have a major problem with this with certificate authorities and RSA and them being broken and not being able to really trust them.
Yeah.
How is there a way does Bitcoin or blockchain technologies look at different approaches that can solve this fundamental authority in a decentralized way? That I mean, you've got blockchain writing and people are got state and they own a piece of it, but how can we trust it with a lot of the attacks and everything from Ethereum and others? How do we trust it?
Yeah.
How do we deal with the fundamental problem with any a certificate or authority issuer in a decentralized world? Be able to trust authority from any one central point or one person, even if it's not central.
Yeah, I mean, that's a problem you always have. So even in the issuance of a passport, for example, then you rely on trusting that the US government is doing passports properly.
That's why the big business and actually people, counterfeiting those. Is there an approach you guys looking at really different, structured? Because the assumption is we have to do it that same way, and I'm saying maybe we need to relook at that because we don't have to. Is there another way? Anybody, not just him, but anyone else has seen? Because the assumption, if there's one single point of failure, is this guy I know somebody's going to find a way to break that or spoof it or whatever. That's what we see.
So yeah, but here there isn't. I mean, repeat the question.
Is there a way to avoid having to depend on an authority issuing certificate? There seems to be a way we can have to trust that.
In this case, I mean, for every credential, you'll have people who've issued that, and you can trust some of them, not others.
But if trust is required, and one of the concepts around blockchain is not having to trust everything, trusting each other.
Yeah, that doesn't necessarily apply here. So you don't have to trust the protocol that how to improve work, but you do need to trust. If someone presents you with a credential and says it's signed by this person, you need to decide whether you trust that person to issue valid credentials.
Why can't we verify instead of trusting?
Yeah, but if the passport authority is signing things saying X is Y, then how do you, there's no way to check that without checking the original passport.
We can talk offline about escalated privilege.
Let's try it offline, and then you'll be around and come up and we can dig deeper into that philosophical question.
Not really.
So, thank you. Recycle back there. If you can help and then three.
Hey guys, one more request here. I'm Mara, your marketing team. I'm looking for more volunteers to help me with this training class. You get a $25 Amazon gift card for some user testing. So if you're interested, come find me here at the front. $25. $25 you'll ever do.
Are we gonna have access to materials?
Ask them.
We're gonna get it going on campus.
We could do a posting that has comments
Oh, okay. Somebody's jacket.
Too well. Would you find
I like 1.5.
There's always, this is
very high pressure. In the traditional,
why do you need salt? Right, so it's kind of coagulated.
Yeah, that's very
Yeah, it's
it's the real person.
So it's like
there's no chlorine thing in the
where
Then whoever creates all of that hash
So the idea is that mission impact, running those expenses. We don't expect every customer to join us. But if we can have some other way of representing them, it's real to work in the states, or we can use that information to power these decisions. Maybe provide some.
He did right anywhere?
Thank you for this. I'm at the decision to.
You can use this information to include so you can also provide
Yes.
Just further along the process.
I think we just got one more. Those guys are they okay?
Yeah, they're for user. So I have this week, but if you want to it is Thursday, and we have active training. I'm not too sure. Yes. So,
So what we're gonna do is
maybe something. Alright guys, I got the tripod. We forgot about that shit. It's 3 minutes. Okay. I love how Uber's like, you can actually shit. And look, it's a rainbow for the people. What's that? Whose laptop?
He was doing some streaming.
Oh, I think that's his.
Video.
Alright, thank you for coming. Bye bye. It's 2 minutes.
Yeah, I need to charge my thing.
Do you have everything? You have your camera?
Yeah, but I need to charge my camera for like.
You can do it at my house.
I think so. It's like that.
Is it really low or something?
Yeah, it's pretty.
Dude, you had all that.
I know, I tried charging it, but it wasn't charging. I swear, it's lucky. It's going to take like
Okay, that's fine. All right. The Uber is here. I'm like, dude, I'm really on the top of the part because like it's yeah, exactly. I don't do this often. Now that
Yeah, but I think it's good used to like being higher.
not like you're in the
Yeah.
I don't know. If I'm working late.
Yeah, that's true.
Should I really get on the bus?
You just work extra hours.
It's a lot of work. It's a crazy spot.
Right.
It's crazy. I want to get like I don't even ride any car that's with your accent. It's like the nicest ingredients. It's like I got it in Tesla Model X. Tesla Model X. Yeah, I started fucking Dubai. You get like Lambos. It's not a thing.
We started here in the meeting for the Monday economic statement. Where it seems to be Florida has been the best because it's the most it's also validating things where it's really what truth and you're able to tie the contrast together so you're able to bring in the realism of the guys and really real key is being able to take what is very risky, uncertain project, drill down and get solutions and but once you get real risk, you know other ways, there's people who want to buy that risk. Insurance, third-party traders, who may have to secondary markets to actually carve out like buy that risk. Because the return tied to the cost. Yes, and then it's our product. Yes, yes. Yeah, so we demonstrate that to the maximum of it's back in the easy access of the markets is not right. Got to go off the that's not our fault. They are there. It's such a shit show. Such a pain point. We need to provide 100%. There's ways across many. What's the model that you so banking, I started banking I started with a called Canada, and then I started to do going on to that same because because Canadians don't invest in the long products, and no one invests in the politics and Northern near Alaska, we're trying to do things. So years ago, transporting oil pipeline, was processing it on so we were shipping clean oil, clean products to China. So it's kind of exactly. So it's trying to deviate Canadian oil away from the rest of the diversified markets. And some guys maybe do some posts, put some bright walls, and show some people some guns. And back all of a sudden you got power. Yeah, for whatever reason. No, that's how it was. Beautiful thing. Yeah, I was doing an actual field plan after that, literally, myself happening. Like, get a good setup, just have to review it, bank, president the next day, I can do it all set up. Yeah, so that's kind of what happened. This year, so we were talking to G, we were using something with the G. And because of the idea of, no, the idea of crowd. No, for real. No, for real. Asking that for me, yes. Like, yeah. And he came out with what he think. That was his theory was that they want those guys in the hotel. That's why I see them. They come to function because they're daily all the skill. So yeah, this gets so long. Lots of questions like, guy from Steven started with 1,000 muscle. It's like an adventure, Apple, first you got a good vision, I have a question. Once you trust, so where do you go? You can guess, these areas, that's here, and we get 5 years, you guess. But the ones, they don't really leave what going on as well. So if you got outside, travel, our job is that's what it is. So it's just a balance. The key thing is, so you're asking questions about and Uganda and South. So Uganda, wow, this is where else? You gotta do it over here. Well, so that process. It's ultimately like that's where they Hey, let's follow up. No, that's just if you go to the interview, you can stop there. Okay, cool.
Hey, what's up? So we originally, we're originally school.
Hey, great job.
Oh crap.